Hi guys, so now we're talking about lesson 3, but before we get started, we're going to go over some notes. So, the first one we have is relation, which is a set of ordered pairs. So, this is pretty basic, a set of ordered pairs. We're just going to be talking about like an x and x comma y. That would be what an ordered pair is in this scenario. Next, we're going to talk about the function. So, the function is one element of the domain is paired exactly with one element of the range. Notice the emphasis on exactly. That means that they can't have different ones. It's paired with exactly only one element of the domain. So all x values are different because they can only be paired with one element of the range. Next one we're going to talk about is the range, or the y's. This can also be referred to as the output, or how tall something is. So usually when you go for the y, it's going to be the vertical part of your graph. The next is going to be our domain, which are the x's, or the input, or how wide it is, which again, so the x's are your horizontal part of the graph, and your y's are the vertical. Next thing we have is a continuous function. So a continuous function means that there's no breaks or holes in that line. Now, since we've just figured out that the continuous means no breaks or holes, now we've got the discrete, which has breaks or holes within its line. So these are just our basic vocab. Now we're going to talk about 4 ways to represent functions. So the first one we have is ordered pairs. So we're just going to put -3, -2, -2, 1, and half, -1. So these are our ordered pairs in one way to represent a function. So our -3, -2, and half are all x's, while our -2, 1, and -1 are our y's. If you notice, all of our x's are different in our ordered pairs, every single one. So now we're going to look at a table. So we've got x on one side, y on the other. We're going to use the exact same ordered pairs from above. So we've got -3, -2, and a half. And then we have -2 goes paired with our -3. Our 1's paired with -2, and our -1 is paired with our half. Again, you notice all our x's are different. Every single one is different, same as our ordered pair. The next one we're going to go through is mapping. So we're going to put all of our x's on one side. We've got our half, our -2, and our -3. And then we have our y's, 1, -1, and -2. With the mapping, you actually draw a line to pair them. So our -3 goes with our -2. Our -2 goes with 1, and our half goes with our -1. Again, there's no repetition within the x's. They are all different, once again. The next one we're going to look at is graphing. So this is just as you would think. You're actually plotting our points. We have our -3, -2 with that big dot. Then we have our -2, 1 with our dot. And our last one is you've got our half with our -1. So what we're going to show that has to pass is all the x's have to be different. The reason why that is we have to be able to show the vertical line test. This shows that our graph is a full function. So when we do a line vertical, so remember up and down, you can see that there's only one x that gets hit with that vertical line. Our next one, same thing, only one x or one dot is hit within that vertical line. Same with our third one. This means that we can pass the vertical line test. Now that we know how to represent, we're going to know how to identify functions. So in ordered pairs, all of the x coordinates must be different in order to be a function, just like we talked about above with all the x's being different. So in our example A, looking at our x functions, we've got a 2, a 4, and an 8. So are 2, 4, and 8 all different? Yes, they are. That means that these ordered pairs can be a function because they all have different x values. So what about example B? We've got 3, -4, and 3. Well, that means not all of our x's are different, which means no, it's not a function. So we're going to do the same thing by identifying a function using the graph. So we've already talked about this one a little bit, the vertical line test. So if we were to draw a vertical line, it may only hit the graph one time. So we showed it above, but we're going to show two examples. So remember, vertical means up and down, and it may only hit the graph one time. So our example A, we've got our little moon here. If I was to draw a line right down the center of that moon, it hits it once and then twice. That means our first example can't be a function because it hits the graph 2 times. Now what about if we look at letter B? We've got one curved line, and when I put a line through it, it only hits it once. If I put another line, it also only hits it once. So that means, yes, that our second part can actually be a function because it passes the vertical line test.